just a few brief words about the Royal Aeronautical Society, really emphasising that it was started in 1866, and the idea was to share knowledge. And some people say, what were the Brits doing at that time? And I did find on the web as ever that Wilbur Wright wrote, saying about 100 years ago, an Englishman, Sir George Cayley, carried the science of flight to a point which it had never reached before, and which had scarcely reached again during the last century. That was written in 1809. So the Brits were doing a little bit, and as I say, the whole idea was to share knowledge, starting in 1866, and that's why we're here, because branches started being formed throughout the world. The Toulouse branch was formed in 1991, and Jordan Claw was the first chairman. There are application forms outside to become a member of the Toulouse branch. That really is an act of faith. We ask you to contribute €10. We're delighted if you join the Mini Society in London, but that will, at the present moment, in the EU, you can deduct your tax from that. May not last. We will say no law about that. Now we're here to welcome Dudley, and he was born in London, close to the side of Bow Bell, which is right in the middle of the city, so he's technically a Cockney. Then he emigrated to London, and he went to Reed College in Portland, Oregon, and left with a BA Mathematics. Then he went to Toronto in Canada and worked on the Aero. I regret I didn't put a picture of that there, which is the first supersonic interceptor way ahead of its time. In 1958, that was cancelled, as these things tend to be. So he went off to Boeing in Seattle, and he worked initially on the 787, and then on Boeing's Supersonic Studies Group, and he was working on aerodynamics and power points. Then a team from Toulouse came across, talked about the Concorde project, so he moved back to Toulouse, where he's been ever since. He also worked on the A300, you will see that, having worked with Boeing on engines. He worked on the engine development group, with Bristol, I think a lot of liaison, and Group Technique Concorde Aerospatiale. He ended up later on being responsible for the overall Concorde aerodynamic development of Aerospatiale, and you can see also, as well as that on the side, he was working on the second generation of SSD, the A300, A320, ATR, and the Hermes European Shuttle space product. And he retired in 1992 as the head of future SSD study.
You'd like to get up now, right?
You can get up, you can stand up now if you can.
Thank you.
So there we are. You know how to work this?
Well, excuse me, people don't wear jackets necessarily. I never wear a jacket except on certain occasions.
Well, we haven't seen it before. You know how to work this, do you?
Yeah, you'll have to stand here just in case.
There you are. Well, I did try and give you some floor instruction.
So I now have to get going. So first of all, can you hear me if I speak from here? No? Use this then. Oh. Can you hear me now? Yeah. Well, first of all, I have to thank the Royal Aeronautical Society for inviting me to give this talk, and of course, being in Toulouse, you will notice we have just about taken the Concorde Toulouse 15 minutes late. We're going to start. This is so I'm quite used to this. It seems almost as if we're starting on time. What I'd like to say though is not only have to thank them, we have to thank also, we had a lot of people, a tremendous financial backing for the Concorde, and it really ought to thank those people. They were known as taxpayers. Now, I don't think when we started the project, when the go-ahead was in November 1962, I don't really think that they quite knew just how generous they were going to be. But nevertheless, I think it's fair to say that from a technological point of view, Concorde was a precursor for everything that happened here, and if it hadn't been for that aeroplane, probably we wouldn't be here tonight. So, without sort of more ado, I will just say, I will start on that. I don't know how to work these things. I lived in the ages we started, they still had steam on the SNCA.
Uh-oh.
Oh,
Nothing happened, you see.
well, you put it blank. There's probably an option there to blank if it's not ever used.
Yeah, with this modern stuff. And that, it might be the end of the talk. Ah,
That's not that one, it's that one there, the one with the arrow.
well, that's one with the arrow on it. Yes. Well, I think that a lot of people here only know roughly Concorde as a shape, but not particularly as an aircraft. So I've just a couple of slides to say that the aircraft by today's standard was quite small, about 185 tons at takeoff, and transatlantic range with 100 passengers in where you have standard, you have tourist, you have business class, you have first class. These people carried, they were class. It was very, very high standard. And of course, we managed to do it. Now, on the same slide, now this is this funny thing. Yeah, there's the fuel tank arrangement. There were 11 fuel tanks, and with no tail, variation of the aerodynamic centre as a function of Mach number. It was absolutely obligatory, as we will see later, to have fuel tank possibility by using fuel, by moving fuel, to move the aircraft CG backwards and forwards, to prevent having to move the other ones down, which was penalising, or up, which was catastrophic. So fuel management was a very, very important part of the aircraft, and for those who are here come from the other side of the channel, it was done in Filton. No. Did it work? No. Went to. I held it down. As you see, this shows the aircraft in cruise, mid-cruise. The engines are running at full power without afterburner. Yes, the specific fuel consumption is for supersonic aircraft extremely low, and in fact for future aircraft some of the American engine manufacturers would not believe that it was that low. You can't get much lower, and you've got 100% efficiency everywhere. It was a very complicated engine and heavy, but it had a very good SFC. So we're flying at maximum LOD attainable, which is, but it does show that had we more thrust, we could move further up and gain aerodynamically. As far as weights go, you'll notice that fuel on takeoff is 50% of takeoff weight. And reserve fuel is, I think, 9%. Hope so. And you have to compare this to the weight of the passengers, which was 6%. Reserve fuel is 50% more than passengers. If you look at the engine installation, as I remember, I sort of go off on tangents, but if you take the passengers with about 10 tons, the weight of the intakes, just the intakes and the doors, I'm not talking about the engines, just that part, 6.7 tons. this is absolutely inconceivable for a subsonic aircraft. So the total engine, total engine, power plant installation was twice the payload. So the aircraft was being pushed to the limits on every transatlantic flight. It was built to do England or Paris, New York, and it did it, and it was not capable of doing very much else. I should point out that its subsonic characteristics, as we see, were very poor, because very low aspect ratio wing. Now, see. That's it. I think it's very important to think, how was the aircraft come about? How did it come about? It was a very complicated aeroplane. Fly-by-wire. It did have a manual backup, which was never used on all axes. Never had a failure such that it had to be used. And it had 4,000 psi hydraulics, saturated at about 100 degrees. It had a wing thickness of, I think, these are coming off the top of my head, 2.2 to about 2.9% thick wing. And on top of all this, it had thermal heating and problems of distortion in flight. And how was it that, I'm not talking about the engine installation, of course they're completely, extremely difficult. But it's not the subject tonight, because it would be a subject just as big as what I'm talking about. But I think part of it came, how did you accept all this stuff? Fuel transfer. It was because in Europe at that time, and this is an example of Sudevi aircraft that actually were built and flew just prior to launch of Concorde studies. I can't think there are six aircraft more different. And of course I would like you to see particularly the Caravelle here. Why? Because it was Henri Perrier who made the remark, and I think he's absolutely right. Had there been no successful Caravelle, the British would never have thought of doing a joint program with the French. So the Caravelle was a key member in there. Now, another part is that I remember when I first came here looking at wind tunnel model, and they gave the wing section. And the wing section said it was the wing section of the Trident. Well, everybody knows the Trident was a 3-engine subsonic plane built by de Havilland's. But what I didn't know was that the Trident was this aircraft up here, which had 2 turbojets on the tips and 3-chamber rocket installation interceptor fighter built by conceived by Monsieur Cervanti. So I shall talk now a little bit about the development of the Super Caravelle. Super Caravelle was going to be an improved Caravelle. It turned out not to be the case. The French officials asked Sud-Est, this is difficult for people who don't live here. Sud-Est, of course, is in the south, west. And Sud-West, who were in Paris. They asked the 2 companies to come up with ideas for a super Caravelle. Well, we just saw the Caravelle. And at Toulouse, Monsieur Vallat who was excellent man for running the design office, they put a lot of effort into making a very big and heavy dossier for their studies of this super caravelle, which I suppose was probably Mach 0.82, something like that, and I don't know what it was like. And he went up to Paris to present it, which he did, but of course Monsieur Vallat wasn't a very big man, so he had this Monsieur Pradel, who was, I don't know what he was in the design office, he was nominated to carry the dossier. Now when they got up there, Blagnac gave this marvellous presentation of how the caravelle would be developed into the super caravelle. And then the official said, well, now, Monsieur Cervanti, would you please present what Sud-West consider? And he said, would you now comment on this super caravelle? He said, well, there's no point. No point in my presenting any of that, because, first of all, I'm in entire agreement with Monsieur Vallat. Excellent work. However, this isn't what we should be doing. And he presented the aircraft that you can see up here. We should be building a Mach supersonic, probably Mach 2 aircraft to fly non-stop across America. And that is how it was hence born, not completely, because it was then, studies were made of supersonic aircraft. Sud Aviation, the two had joined by then, got the contract to develop studies for this aircraft. As you can see, I won't go on about it because it's on the next slide. The French people here, they can probably read it more easily than the English, but the English can read it anyway. Monsieur, there's a beautiful pair of books, or I think it's all in one thing, by Icare, which is a review put out by French Airline Pilots Syndicate, and all about the Concorde. And although I know this story because I've got other documentation at home, Monsieur Cormery wrote it down so well that I just cribbed it. As you can see, they started off with, like many other aircraft at that time, with a foreplane. And they went into the wind tunnel, and the first thing that happened, low speed, complete loss of lateral stability, because the wake coming off the foreplane interacted with the fin, and so they had to add fins outboard as well. The aircraft in the end ended up with 3 fins. But this was bad too, because the intersection of the leading edge of the outboard fins, the side ones, interfered with the vortex springing down the wing and caused pitch up. So they came to the conclusion that first, as he says, is le goût de la difficulté. they really were on the knife edge. They thought that perhaps it might be a valid arrangement. However, at that time, by modifying the wing, and we'll talk about that in a moment, and going to an ogive shape, the vortices moved further out, and they allowed the fins to work properly outboard. Still a tendency to pitch up, but it was much better, and you were able, by adding this shape, to move the engine installation completely under the wing. And as he said, it was they thought they were, yes, we thought we were nearly there. Now, he, well, being head of aerodynamics, I don't know whether they do that now, but he spent a lot of time in the wind tunnel himself. And he, with a person who people who remember things, Michel Huret, they were in the tunnel and they thought the wake coming from this foreplane, if we added an extension up, then the wake from the foreplane would follow the extension and we'd maybe be home and dry. So they built this up in the tunnel using such high class and high technical materials as plasticine and cardboard and so on, and they tried it and it worked. And then they found we don't need any canal anymore. We don't need the foreplane. And of course the aircraft no longer balanced. They had to move the fuselage back. On the original configuration there was interaction from a wave track point of view between the rear fuselage and the wing, which was bad. By moving it back, the area distribution became good, and voila, there they had something. Fiat loops. It's marvellous. There's I'm a great admirer of Monsieur Cormorant, as you will. Oh dear, what's happening now? Yeah, they've got here. It's very clever. It shows you what you're showing and what you're going to show. Of course,
well, we've got to look at the right one, which I wasn't.
I think that the time has come for me now to read the text. How did the Concorde come about? Why did Britain and France decide to get together? And I went to a meeting in London in 1998, and there was the Right Honourable Aubrey Jones there. Pretty ancient, rather like me now. He was in a wheelchair, but I'm not. And he could hardly speak, which again is different. And but they read out what he said, and I'm going to read it to you because I think it's not very well known how this project started. I was Minister of Supply under Harold Macmillan as Prime Minister between the beginning of 1957 and October 1959. The Ministry of Supply procured weapons for the armed forces and sponsored the aircraft industry. In March 1959, there came into my hands a report from a technical committee headed by the Royal Aircraft Establishment at Farnborough on a supersonic passenger aircraft and advocating that something should be done about it. So I thereupon placed design contracts with Hawker Siddeley and Brussels. In June 1959, I took the advantage of a visit to the Paris Air Show at Le Bourget to speak with the French Minister of Transport. I don't know who he was, but we spoke in French. For before the Second World War, I had been a correspondent in Paris for the Times. I suggested we should jointly develop a supersonic aircraft. My motives were twofold. First, he writes so well, so embarrassing, I became weary of the Treasury's cancellation of most aircraft projects. and the Treasury might find it difficult to cancel a project undertaken jointly with another country. Second, I believed that as a country we had made a mistake in holding ourselves aloof from the European common market. So, cooperation with France in an aircraft project might be a partial remedy for that mistake. My suggestion was enthusiastically taken up, and thus was Concorde born. I am proud to have been present at the birth. I think it's worth saying. So that's how they came together. And well, they didn't come together. That's how they were told to start looking at things together. Now, in England, the project had been started by the RAE at Farnborough, and someone who really pushed it into a tremendous amount was Dr. Dietrich Kuschmann, who was an enthusiast and really pushed the slender delta with what he called controlled separated flow around the wing. This, however, far too low an aspect ratio, and Bristol's had slowly moved ahead, and in August 1961 they had the Bristol Type 198, a transatlantic aircraft, 385,000 pound takeoff weight, Mark II, and powered by 6 Olympus engines. How they were hoping to... maintenance on that centre engine would have been a bit different, and the intakes wouldn't have worked probably, but anyway, that was where it was. It was a big aircraft, much, much bigger than the French Super Caravelle, which was a medium-range aircraft, and much lighter. Well, in November, there was a meeting in London, and they said we must now start heading towards a common configuration. And so, thus was this next one, the now BAC, it's no longer BAL, no longer Bristol's, it's Bristol British Aerospace Aircraft Company, the Type 223, which was a smaller aircraft and could be compared much more closely with a Super Caravelle on the technical basis. And you'll notice that both it and the previous aircraft, the whole of the passenger cabin, it ends here. This part is unpressurized, so all the landing gear and the power plant installation is behind the cabin. The fuselage is flattened and area ruled, and probably a bit heavier than the round one, but of course there was no drag due to engine wheel fairings because they went into the fuselage behind the cabin. This all converged. This aircraft then had a very short life from November 61 until January 62. And where a common configuration was given to both companies so that they could both look at the project and both come together as to what they thought the best solution was. You will notice that it has quite Concorde-like. In fact, it had the Super Caravelle wing, which is Cervantes' wing, and which we'll talk about in a moment. And one of the options, however, luckily, was variable geometry nose. Talk about that too. Now this is an important document which I never knew existed, but in fact did. it is part of the treaty between France and England. So it's extremely binding. They went through the whole aircraft, what different people should do, different parts. And one of them, of course, aerodynamics. And as they said, the British are responsible for the design of the whole of the power, aerodynamic design for the whole of the power plant system. A tremendous, difficult job. And also for the calculation of performance and also for the